All right, this is what we looked at during our Google Hangouts meeting on Thursday, and I just want to re-go through this again in this video. So the problem was asking if we have this amount of steam and this amount of ice, and they're combined, what's going to be the final temperature of the one substance, the steam and the ice? So I always start here. This is my notes here. I always start here, and just so I can see visually, I'm a visual person, so I need to turn this into a picture. So I'm just showing here that we're starting at ice. Down here at the bottom, we have 50 grams of ice at 0 degrees. And up here, we're starting at steam. We have 10 grams of steam at 100 degrees. And I know whenever these two substances mixed together, the final temperature is going to be somewhere in the water section, in the liquid water, between 0 and 100. I wouldn't necessarily be able to assume that if I had like a superheated steam, if my steam was 200 degrees, or if my ice was -50, I wouldn't be able to necessarily assume that it was going to be right there in the water, depending on how much mass of each you have, if that makes sense. But here, we're right at 100, right at 50, so they're going to change phase right away, and the final temperature will be in the water section. So what I do is I just set each side, the heat that the steam is going to lose, because it's going to a lower energy state, is going to be equal to the heat that the ice is going to gain, because the ice is going to a higher energy state. So the two equations you're going to need for heat: the top equation is to calculate heat during a temperature change. The bottom calculation is to calculate heat during a phase change. Both of these substances, steam and ice, are going to go through a phase change as they jump through evaporation. So the steam is going to go through evaporation and then land in water. The ice is going to go through melting and then go into water. So we have to account for both of those phase changes, the heat during that, and then the heat it takes for the steam to drop from 100 degrees, and the heat it takes for the ice to increase from 0 degrees to whatever our final temperature is. Okay, so our total Q for steam, total Q for ice, set those equal. Here, M equals LV. That's my phase change formula. My LV is for vaporization. That's here for steam. And then MCP delta T, that's for our temperature change for steam. And then ice, our phase change for ice is MLF, mass times the latent heat of fusion, plus MCP delta T. Okay, so that's how we set up this problem. You just set each side equal, grab the heat formula, set each side equal. Now here, I always use this kind of table, just another visual thing for me, just to keep everything super straight, to keep things positive on both sides. So I set my 0 over here for ice, my 100 over here, and I know in the middle is going to be their final temperature. So whenever I input in my delta T's, this helps me with my delta T section up here. So this side of the formula, we're keeping it all the information about steam. This side of the equals, we're keeping it all the information about ice. So my delta T section is right here, 100 minus TF. And so my steam section here, 100 and TF, the difference between here and here is my temperature. I know TF is going to be smaller, so I'm setting up my equation to be 100 minus TF to keep it positive. And then over here is ice. And over here the TF is greater than 0, so I'm going to keep my equation positive by putting TF first, TF minus 0 right here. That I should say 0. So that's just a way that I use to set up my my temperatures and then keeping them positive. You can do that because one is on each side of the equation. So then at this point it's just algebra. Here I combined this, multiplied here, then I multiplied here and just carried this part down, multiplied here, multiplied here, and then carried that down. Next, I distributed this 41,860, distributed it here and here, distributed over here, copied down again, and then subtracted on both sides, subtracted over here, added over here, and we get to our final temperature of 39.96. This is all just the algebra to solve for TF. So if you get a problem that asks you the clue words that you're going to remember when you're reading a problem like this, if there's one on your quest or on your exam, is steam and ice. So you have two subjects, two substances that we're going to mix, and we're trying to find a final temperature, or we're mixing them and maybe your final temperature is given and you're looking for the mass to solve for how much of something you have. So this is how you're going to set it up. Just the entire heat, set them both equal. This substance is heat, this substance is heat, and make sure you know, is it going through a phase change or not? This is an example of two of the same substance, H2O, going through a phase change. Now, there was another problem. The other video that we looked at was two different substances, water and aluminum, that were exchanging heat. So there was no phase change there, but that's on the other video. If you have any questions about this, let me know.